Not yet. We're still not there. Maybe you can do that study if you become a theoretical physicist. So now this is wave particle duality. But of course, in physics, if energy can become matter, it means that matter
can become energy.
yes, that's the whole thing. So here we said if matter behaves like a wave, what else is true?
That waves behave like matter.
So the example is here, the solar mill, right?
Yeah.
Do you want me to touch
I'm
on that
just
again?
highlighting this part.
Yeah, yeah. So
No, can I explain based on the notes that I took
yes,
for
please.
the solar wind? Okay, so first of all, I started by describing what was said. So you had this windmill inside a vacuum,
Mhm.
and right after that, wait, I said windmill inside a vacuum. Right after that, I said electrons diffract, which is wave behavior. And then right after that, I said when light was shining through the metallic surfaces, the windmill was moving because in this case, light behaves like a wave, which has enough force to push the windmill to move because of the photons.
But well, here you want the wave. You know that light is waves, right?
Yeah.
So you want to say the wave can behave like matter. So we know that in general, we were told that light is electromagnetic waves, right?
Yes.
So we don't expect such a wave to have anything to do with material behavior, you know.
Yeah.
However, like pushing, like having a force, having momentum, isn't it? We don't expect that from a wave, do we?
Don't. We don't.
At a macro scale, no matter how bright the sun shines, you don't expect yourself to fall back, right? Because of the sun shining.
Yeah.
But now what we are learning is indeed theoretically it's possible for a star, for light to push things. Are we together?
Okay.
Light is a
I
wave.
think you,
Light,
sir, I think you might need to write this like very concisely because I'm trying to understand it still, but
okay.
I see the parts.
So light can push things. So in other words, in quotes, right? Light can push things, you know. So light can push things. So here you're talking about what? Momentum, right?
Yeah.
Momentum or maybe force. All of this pertains to what?
Pertains to the movement.
No, no, what we're saying, look, we're talking about the duality here. Now we're in the duality. What do we call this duality?
You
I,
just call it duality.
I wrote it up here, Hosanna.
Wave particle duality. Sorry,
So
sorry.
think wave particle duality. So now I come here and say light can push things. So in this case, light can push things. The word push has to do with which part of the duality?
The particle part.
Excellent. So particle, because we know particles have got mass, don't they?
Yeah.
So
And they, yeah.
yes, you were saying they.
No, 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 no. I was
No,
like, because
feel
they
free to
have math.
express yourself.
I was just thinking because they have maths and sometimes velocity, they're able to move around. Like they're very dynamic and they can have momentum. Like a
The
specific
keyword
particle can have.
dynamics.
Oh, okay. So it was right.
Yeah.
So wait,
However, what do we say about light?
light is an electromagnetic wave.
Good. So
It's a
light is a
wave,
wave. Light is a wave. Good. So we don't expect a wave to behave like a,
like a particle.
but that's what we see here in the solar winds. Is a classic example, isn't it?
Yeah.
Now we just want to fine tune it. Light is a wave. Of course, Einstein later told us that of course it can also be considered as traveling in photons. So photons are particles of energy, packets of energy, not particles, packages of energy. But forget about that. Just think about light is being a wave. We don't expect a wave to push
Okay.
anything. However, this wave interacts with this shiny surface, metallic surface, and pushes it, especially in a special condition whereby you have a vacuum. and a small enough machine, to overcome all the constraints, such as friction, and all of that. And this actually is a reality. So is
Yeah.
it a particle that pushes these vanes so that this windmill turns? It's not a particle. Actually, it's a wave causing that. So it's just a wave behaving
Particle.
as a particle. Maybe we can leave it at that right now, so we don't have to speculate. Let's leave it at that. So all of this has to do with the wave particle duality. And of course, now you should be able to likewise give me an example of a particle behaving as a wave. Can you summon that example quickly?
Particle behaving like a wave is when the electron diffracts.
Excellent. So you got it.